All right, scholars, we are going on to now the process of proving triangles congruent. Now on lesson 4.3, we actually did like 10-step proofs or so because we had to show 3 pairs of congruent sides and 3 pairs of congruent angles in order to prove the triangle is congruent, because the definition of congruent polygon says all the corresponding angles have to be congruent and all the corresponding side pairs have to be congruent. So you end up with 6 things. But today I'm claiming that you only need to ever do 3. And the first thing is called the property of triangle rigidity. Remember, if something is rigid, it means it's unchanging. So picture this right here. If I have a triangle with a segment that size, one this size, and let's say one like this, we make a triangle, right? But what if I changed order? Like maybe I want to put it here, and then I want to put the blue one, oops, the blue one didn't go, and I wanted it to do here, and the red one went here. Did anything really happen with that triangle? No, I still made a triangle out of those 3 sides, and those 3 sides still make the same size triangle. So notice if I put this stuff back to where they were, see if I can do it again. Move this one back here, move this one here. Was that the same size triangle as the first one that I had originally and the second one I had? Yeah, the cool thing is that we know that if I have 3 segments that make a triangle, no matter how I put them together, I'm always going to make that exact same size triangle. So I'm going to have congruent triangles. So here's what the triangle rigidity says. The property of triangle rigidity, as this moved, notice that will move all the words. Let's see if I can get this whole thing to move up here. See, go right here. This is what I get for using technology, trying to be fancy, guys. The property of triangle rigidity gives you a shortcut for proving 2 triangles are congruent. It states that if the side lengths of a triangle are given, the triangle can only have one shape. And only one shape. It can be flipped over, it can be on its side, but it can still only ever have one shape and one size. So that allows us to actually have a postulate, and it's called the side-side-side congruence postulate, and we abbreviate it as SSS congruence. Now, when we abbreviate in this chapter, the letters represent pairs, okay? So if I say side-side-side, that means I'm representing 3 pairs of congruent sides. So here's what the postulate says. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So when I look at these, I need to make sure I'm matching pairs. So like here I have those that are both 7 right here, congruent. I have ones that are both 6 centimeters that are congruent. And then I have the ones that are red that are also congruent. And notice for one of those triangles, I marked what I was marking my pairs with. I was marking as if they are sides. And notice it actually goes side, 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 all the way around the triangle. It's a way of letting me be able to know how the triangles are congruent. A few things you need to remember. Adjacent triangles. So adjacent triangles mean they're next to each other. And you guys agree with me that this triangle right here and this triangle right here, they're both share a common side. And so a lot of times we'll use that reflexive property like we did in our proofs yesterday. So hopefully that was kind of helpful and you were able to get it. All right, so moving on with this, let's see how we can do here. Let's actually try applying this a little bit. Now, we're kind of doing an informal proof when we're doing this one, but I think it's actually pretty easy. It says use side, side, side to explain why triangle ABC is congruent. So do you guys agree with me? If I look here, segment BC is being shared in both triangles, so by the reflexive property. So that's the first thing I'm going to say. Segment BC is congruent to segment BC by the reflexive property. Also, it was given in our diagram that segment AB is congruent to segment DB and segment AC is congruent to segment DC, right? So there are 3 pairs of congruent corresponding sides. So therefore I know triangle ABC is congruent to triangle DBC. Now remember, we showed how many pairs? And notice I only ever mark it on one triangle. 3 pairs of congruent sides, and it goes SSS. So therefore, the triangles are congruent by the side congruence. And I do want the congruent symbol with that because we actually have stuff that's not with congruency that we'd still use this abbreviation for. So that would be almost like a mini proof, right? Almost like a paragraph proof. All right, let's look at the next one. We're talking about some terminology that you needed to know. It's talking about the word included angle, and really, it really means between angle when you hear the word included. An angle's included, okay, when it is formed by 2 adjacent sides, or consecutive sides is another way of a polygon. So in this case, segment AB and segment BC would be considered adjacent sides or consecutive sides, and it's included between AB and BC. So the idea, it's between. So included means between. Everyone make sure you understand that. Included means between. So think about this. Angle C would be the included angle for which one? Angle between what 2 sides? So if I'm looking at this angle, what 2 sides surround it? Oh well, or make it. That'd be segment AC and segment BC, okay? Now, what would A be? So let's look at A. What would it be the included angle for? It is the included angle for, that's right, segment AB and segment AC. So understand how you're working with these. All right. Now we actually have another one. When we're working with this, we're talking about what's called the side angle side congruence postulate. Now guys, location means everything. How the letters are spelled, put together, tells us something. And also, that also means how it has to be located on the actual triangle itself. So side angle side congruence. So without writing anything down, how many pairs of congruent sides do you think we're going to need? That's right, you're going to need 2 pairs of congruent sides. And how many pairs of congruent angles do you think we're going to need? Yeah, we need 1 pair of corresponding congruent angles. So that's why it spells side angle side. But here's the thing. Where does the angle have to be located? The angle has to be located between the 2 pairs of congruent sides. So that's why it's called the included angle. All right, so let's fill this one in. And this is a theorem you'd want to make sure you have memorized, but it's also one that I would definitely use the abbreviation if I was doing this, side angle side congruence. All right, I must admit, this is my favorite theorem because you can have some SAS, got it? SAS, and still be correct in math. So once you use some SAS, which is always my favorite thing, you can use it, use this theorem. All right, so if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Now, notice how they're marked here on the diagram. I always say mark one of them. Notice I have a pair of sides congruent that are marked, a pair of angles that are congruent, and then a pair of sides. And where's that angle located? Between the 2 sides. So when I look at that, and I can literally spell SAS, now it has to spell SAS, like literally adjacent sides with the A in the middle, I know the 2 triangles are congruent to each other. And I like this because it says, no, caution, the letters of SAS are written in that order between the congruent angles because the congruent angles must be between the pairs of congruent corresponding sides. So it has to be that way or it's not congruent. So let me show you what I mean here. Example 2. The diagram shows part of the support structure for a tower. Use side angle side congruence to explain why triangle XYZ is congruent to triangle VWZ. So when I'm looking at this diagram initially, do you see that there are 2 pairs of congruent sides? Great. But I either need another pair of congruent sides or I need a pair of congruent angles. So remember, when you're working with triangles, you always need to have groups of 3. So 3 pairs of things that are congruent. Looking at this, it doesn't look like I have anything congruent, but if you look at the diagram carefully, you probably recognize you have a pair of vertical angles. So here's really cool. So let's write this down so we can explain what we're doing. So we have here angle XZY is congruent to angle VZW because of the vertical angle theorem, right? The 2 angles are included between 2 pairs of congruent corresponding sides, right? Which would be, and let's show what they are, sides. I'm going to write that a little bit, which would be segment XZ is congruent to segment VZ. And we had segment, I should probably use a little bit more proper grammar there. And segment YZ is congruent to segment WZ.
Is Steve felt strongly enough about meeting today? Yeah.
So therefore, triangle XYZ is congruent to triangle VWZ by side, angle, side, congruence. I think it's theorem, right? I'm sitting there saying postulate, but nope, it's postulate. Here we go. Postulate. Therefore, triangle XYZ is congruent to triangle VWZ by side, angle, side, postulate. Now, guys, look if I labeled my diagram. Look where the side, angle, side, like if I go around the triangle, it actually spells SAS. Let's do with proof together, okay? It is not that bad, but now here's the cool thing. Remember, yesterday we had like 10 steps. Today we'll have like 5 to 7, ish. But the thing is, I have to have 3 pairs of corresponding things congruent. So again, it could either be side, 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 or side, angle, side. Those are the only 2 that we're working with congruency. But let's use our given information to help us out. So let's go with our 2 columns here. It's also really helpful to label your proofs with side S or A to see what you were actually given for pairs of correspondence. So that will help us a little bit. So let's do the first one. We have segment PN bisects segment MO, and that's given. And the fact then I'm going to have, so PN bisects segment MO, so that's a segment bisector. If I give you a segment bisector, you give me 2 congruent segments. And that's just definition of a segment bisector. As if you have a segment bisector, you have 2 congruent segments. All right, then if you're stuck, then we go back to our given. So by the way, that gives me a pair of congruent sides, doesn't it? A pair of congruent sides. We're also given that segment PN is perpendicular to segment MO. That's given. And if I have perpendicular segments, they form what type of angles? Right angles. Again, don't tell me 90. I don't want to do algebra right now. I just want to get really easy stuff here. So the very next thing I'm going to write down, because I need a pair of congruent angles, right? The fact that angle MNP and angle ONP are right angles. So that would be definition of perpendicular lines. And then number 5, angle MNP are congruent to angle ONP. And so it would be all right angles are congruent. So that gives me an A, right? So side angle. Now, I need one more pair of sides. All right, does anyone see another pair of corresponding sides for these 2 triangles? Yeah, I'm glad you guys caught it right away. It is going to be, and I love this, I'm going to highlight it for a moment. They're going to be reflexive. That's right. So here we go. So we know segment PN is congruent to segment PN by the reflexive property. So side, right? So side angle what? Side. So therefore I know triangle MNP is congruent to triangle ONP by side angle side congruence postulate. So it's for some SAS, right? Side angle side congruence. Now, guys, notice that wasn't a real difficult proof if I used my given. Don't forget the reflexive property is used very often. All right, now we're going to do another one. This is a little bit harder problem, but I actually don't think it's going to be that hard for you. It says, show that the triangles are congruent for the given value of the variable. And we have triangle MNO is congruent to triangle PQR when X is equal to 5. So here's what we have to do. First of all, we got to show what each one of these are. So if QR equals 5, guys, which side is it congruent to? So we know segment NO is going to be congruent to segment, probably would say QR here. Oops, right? NO would be QR, yep. Looking at my congruence statement, if I can write a congruent symbol here. Wow, you can tell I don't have you guys correcting me right now while I'm doing this video. So that's the first one. Then let's look at segment QP. That's just going to be 5 plus 2, which is 7. So that means I know segment NM is congruent to segment QP. So now, guys, what does that give me here? So I have a side, I need another pair of sides, right? So segment RP is going to be 3 times 5 minus 9, which equals 6. So segment MO is congruent to segment PR. So look at my diagram. What do I have labeled on my triangle? I have 3 S's, right? So are these triangles congruent? Because remember, here's how I mark these, okay? Notice I only mark on one triangle so I don't get confused. And I mark every pair of corresponding parts that I have, either as angle or sides. And remember, I only need 3. So I have side, side, side marked. So if I have 3 pairs of congruent sides, do I have congruent triangles? And the answer is yes. And so that's what we're going to say. So since 3 pairs of corresponding sides are congruent, triangle MNO is congruent to triangle PQR by the side, side, side congruence postulate. What do you guys think so far? Hard, easy? Well, guys, you are going to have proofs, but I don't think these proofs are going to be that hard, especially if you use example 3 as like your guide. But now here's something that I will do with you. And first of all, there's a huge typo here. Guess what they need for each one of these congruent symbols, all right? We can't just say side, side, side because there's such a thing as side, side, side similarity or side, side, side similarity theorems. So we can't use those. But right now, you're supposed to look at these diagrams, the triangles they give you, and decide if you can prove the triangles congruent, either by using side, side, side congruence or side angle side congruence. If neither one of them can be used, you just sit there and say neither to be proved congruent. So when I'm looking at this one, the first thing I do is I mark up what I know. I have a pair of sides congruent and I have a pair of angles. But I have another pair of sides, right? But guys, the angle has to be between the sides. Is the angle between the sides? No, it would need to be over here in order for that to work, but it is not. So since it isn't, side, side angle, first of all, it's in the wrong order, but it's also the angle is in the wrong location. And remember, location is everything. It has to be included. So in this case, that would be neither. All right, so here's some hints. I marked my pairs of congruency together. I also made sure that I would almost spell out what I have either by going clockwise or counterclockwise, so be really careful. All right, let's look at example 2 here. All right, for example 2, we have a pair of sides that are both 4. I have a pair of sides that are both 3. And then I have a pair of right angles that are congruent, and they're included. So I have here side, angle, what? Side. So are the triangles congruent? Yes. So use side, angle, side, congruence. All right, let's look at the next one. I have a pair of sides, I have a pair of sides, and then I have an angle. What's the problem here? That spells what? Side, side, angle. The angle is in the wrong location. So it's neither. And they're not congruent. These triangles could not be proven congruent. All right, let's look at the last one here. I have a pair of sides that are both 6, another pair of sides that are both 4, and a pair of sides that are both 7. That's awesome. So I only wanted to mark one side and I ended up marking 2. If I look around that triangle and go in order, what does it spell? It spells side, 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 congruence. So those triangles are congruent by the side, side, side congruence postulate. This is using the idea of the triangle rigidity. All right, so you're going to have to be able to do this well, guys. Be able to look at it and tell me if they're congruent or not. All right, let's do the next one. Now this says find the value of x so that the triangles are congruent. Well, remember, in order for them to be congruent, we have to kind of assume that they're congruent. So what do I know so far? Well, I have a pair of sides here that are congruent, and I have a reflexive sides that are congruent, and then I have the third pair of sides need to be what? Need a third pair of sides to be what? All right, so in order for them to, if I need them to be congruent, I have to assume that they're what? Congruent. So I need that third pair congruent. So what are we going to do? We're just going to set it equal to each other. So 22x minus 3.6 is equal to 20x. Subtract it over, negative 3.6 equals a negative 2x. X is going to equal 1.8. Show your work. Okay, now look at this one, scholars. I have a pair of sides. I have a pair of sides, but I don't have the third pair of sides, so I can't use that. But maybe I could use the fact of my angles. So I need to use the side angle side. So I need to show congruent angles. So we're going to set them equal. So I got 6x minus 27 is equal to 4x plus 7. So it'd be 2x equals 34. X is going to equal 17. All right, hopefully these will help you on here, guys. This can be kind of hard at first. Homework is the textbook problems and homework supplement. And the homework supplement is proofs. I think there's a total of 4 proofs. On the homework, make sure you mark your given, use your given wisely. And if you take one of the triangles and you mark side or angle for every part congruent, it should tell you which one to use, either side, 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 or side, angle, side, congruence. All right, guys, I should be home on Sunday afternoon and evening, so please just feel free to give me a call. I'm gone from 4 to 6 for a small group, but otherwise after that, we're good. All right, I will talk to you guys soon.